All right, so continuing to add things across this double bond. Next up, we're going to take a look at halogenation. And so here we're going to add some halogens, of course. And so here we're going to add addition of X2, where X is bromine or chlorine, right? So we can add halogens across our double bond. And so if we took a look at a double bond and we did this reaction in real life, right, just Br2 itself, we would end up with two products here. We'd end up with this product. And then this product. And so what you can see is one is a wedge, one is a dash. And so we have not done syn addition, we've done anti-addition. And so let's take a look at this mechanism and see why we only get this anti-addition. So first off, we start off with a nucleophilic attack from our alkene onto our Br2. And so then what we form here is a three-membered ring similar to that mercurium ion. This is what's known as a brominium ion or bromonium ion, right? Has this positive charge right there. And so these things can be either wedges or dash, right? The bromine can add on the top or the bottom, depending, which way it attacks. And then the second step is an Sn2 attack on one of these carbons and then kick off one of these bonds, right? So this is an Sn2 type of attack. And so if we're thinking of Sn2 type of attack, we're talking about this backside attack. And so that's going to result in our anti-addition, right? We form this three-membered bromonium ion, and then we have this Sn2 type of attack. And so you can see how that mechanism explains this purely anti-addition that we get. We get no syn addition here. And so then, of course, you have to think about the stereochemistry when you're adding across double bonds. So, for example, here we would get two products, right? This product and then the enantiomer. And these two are, in fact, different compounds. But then when we have this kind of trans alkene here, this symmetric trans alkene, we only get one product. And the reason we only get one product is because this compound is meso, right? If you rotate it about this double bond, what we'd end up is both of these wedge, and then there's this mirror plane. So think back to kind of exam one, where we saw examples of this. But again, you want to relate the mechanism to the final product, and then you want to draw parallels to this mechanism and our oxymercuration demercuration mechanism. They're very similar.